Okay, so this is lesson 7.1. We're going to finish it today, and then you're going to have time in class to work on those problems. So we want to look at some applications of this right triangle trigonometry. Right triangle trig has lots of real-world applications. That is why it was found, started, invented, however you want to think about it. So it is very essential that we understand the application. So let's take a look at this example we see here. It says that a competitor in a hiking competition must climb up the incline course as shown to reach the finish line. Determine the distance in feet that the competitor must hike to reach the finish line. Now, do you see how it says the number in feet, but they've listed this as a mile? So the first thing I would suggest doing, let's go ahead and rewrite this as 5,280 feet. So knowing that conversion is super important. Now, think about what we've done in the past. I believe it was the ones labeled example 3, so the last examples we had done. We had been given two sides and an angle, and we were in charge of finding something. So let's label everything we know. This would be our theta. This is our hypotenuse. This is our adjacent. So when we are looking at which of the formulas, sine, cosine, or tangent, remember sine was opposite over hypotenuse, so cosine is adjacent over hypotenuse, ca. Tangent is opposite over adjacent, toa, so ca, toa. The one that contains adjacent and hypotenuse would be the cosine. So let's write down that formula. I know that the cosine of angle theta is our opposite over our hypotenuse. I'm sorry, adjacent over hypotenuse. Wondered why you guys were looking at me like that. Is our adjacent over our hypotenuse. So that A over H, adjacent over hypotenuse. Now let's take the information we have and let's plop it into our formula. So I know that the cosine of 48 degrees is adjacent 5,280 over our hypotenuse x. Now our hypotenuse should be our longest angle, so we should expect that this guy has to do more than a mile, more than 5,280 feet. So as you go through this process, expect a number more than 5,280. Now, the first thing I would suggest doing, we are going to determine the distance in feet. So let's assume we want the nearest foot. We're going to do the cosine of 48 degrees. Now you want to make sure your calculator reads that DEG in the bottom left right corner of your screen on your calculator. And we're going to write that out quite a few decimal places. So I just kind of read it, or you can just keep it in your calculator as a, hey, it's waiting for me. Okay. Now, the cosine of 48 degrees is 0.669130606. It's whatever that is right there. Now, remember, in order to solve for x, it is the denominator on the right side. It is dividing by x on the right side. So to put it in a location that's going to allow us to solve it, we're going to need to always cross multiply by the denominator, whether it's a number or an x. So we get at this point 0.6691306 x equals 5,280. So that coefficient, that multiplication of 0.6691306, we have to divide both sides by that value in order to solve for it. Now remember, we should expect that we're going to get an answer that is more than 5,280 because it is our hypotenuse. So if we look at that, we do indeed, rounded to the nearest whole foot, get 7,891 feet. Now, for a real-life application like this, please, 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 please write your units. If they don't tell you how to round, I want degrees rounded to the nearest whole degree, and I want side lengths to the nearest tenth. If they don't tell us, let's do angles to the nearest degree and sides to the nearest tenth. Okay, so we know that this guy has to hike up the mountain 7,891 feet. Okay, do we have any questions about our first application? Do we have any questions about that? Okay. So now let's talk about how we find missing angles. Now, what's interesting is this notation you can see on your calculator. That notation is only used when we are trying to find missing angles. So that little notation is only used if it's an angle that we want to find. So this is the inverse sign. We say it inverse sign. It is not it's not really to a -1 power. It's not the reciprocal. It's nothing like that. It is just a notation that you have to know. The inverse sign of the opposite over hypotenuse, or you can see some older textbooks use arc sign instead of inverse sign. Arc cosine instead of inverse cosine. Arc tangent instead of inverse tangent. Those are allowing us to find for a missing theta. Now, if our calculator is in degree mode, it's going to give us degrees. If our calculator is in radian mode, it's going to give us radians. Now, we haven't explored what a radian is, but we're going to get there, okay? So this is just notation, so you have to know that that little -1 or an arc in front of the sine, cosine, or tangent, and it's the same thing if it's a secant, cosecant, and cotangent. That notation means I'm looking for an angle, okay? So it's a notational thing that you just have to understand what it means, okay? Everybody have that written down? Okay. So now let's look at a just a simple kind of triangle bin setup. Example 5 here says find a missing angle measure. See how it says round to the nearest degree? Use a trig function to find the measure. Now, what's interesting is we start it almost exactly like if we're missing a side. In relationship to where this angle is sitting, this one here is our opposite. Label it. This one here is our hypotenuse. Label it. Find the correct one that matches your SOHCAHTOA. The one that uses opposite and hypotenuse is the sine. Write down the formula. The sine of theta is opposite over hypotenuse. So you'll see how it's exactly the same procedure that we did example 3. We labeled the sine, the sides, or the angles, whatever we had to label. We found the appropriate trig function. We wrote the formula down. So you'll notice nothing has changed from what we did for the example 3. But now let's put everything in. We don't know theta, so we're going to leave it. We do know that our opposite is 12 and our hypotenuse is 15.7. The fraction for a sine should always be a proper fraction. The fraction for a sine should always be a proper fraction because you're putting it over your hypotenuse. That numerator should always be smaller than your denominator. Okay. Now it's a calculator problem. Theta is the inverse sign of that fraction we're going to put into our calculator. Now, that is the only time in our calculator that when we are doing a trig function, that is the only time that we hit the second button. That is the only time when you are missing an angle on your calculator that when we're dealing with trig do we hit the second button. So let's practice entering it. So if you guys got a calculator off the bat, make sure your calculator's in degree mode. You're going to hit second and then sign, and then you should see that inverse notation with the little -1 pop up. Then you're going to type in, because one parenthesis is there, you're going to type in 12 divided by 15.7. You can end your parenthesis, but if there's nothing else coming, you don't really have to, but you can. And then you hit equals. Now, round, please, to the nearest degree like the instructions told us. So most of the time, again, angles go to the nearest degree, sides go to the nearest tenth, unless they tell you otherwise. For me, that's what I want. And then mark it accordingly. So that angle has to be to the nearest degree, 50 degrees. So make sure you understand how to do that on your calculator. Again, you can do some of this stuff in Desmos, but it defaults to radians, so make sure you have it in degree mode, or you'll get the wrong answer. Does everybody understand how we look for an angle measure on our calculator? Second, and then the appropriate trig function. And that little -1 notation should pop up. You only do that if you're missing an angle. Okay, so that is example 5. Here is a real world example, example 6. Now this is an example of an angle of elevation. We are going to be working on those tomorrow. So we're going to be doing some applications of our trig functions tomorrow and the next day, the rest of the week. How about that? So let's read this problem. It says a person on an airplane, so there's a little guy right here, and they look down at an angle of elevation. So their head was, if their head was straight, that would be this, but they have to drop their head down 15 degrees, and then they will be looking at a point on the ground. So there's something on the ground they found was interesting. They're looking out the window. They drop their head 15 degrees to look at it. That's the scenario we see there. Now, the plane is at an altitude of 10,000 feet. The question is how far is the person from the point on the ground to the nearest foot? So you'll notice that this side of our triangle we do know is 10,000. That's the perpendicular height from the ground. The distance from the person in the plane that's looking to the point on the ground is what we're trying to find. So label that on your triangle as your X. Now, the problem for angle of, this is an angle of depression, when you are above something and looking downward. The angle 15 degrees is not in our triangle. So I'm going to show you how to put it there, okay? If this was, let's say, a bug on the ground, and the bug needed to lift their eyes to find the person's window, the bug would have to lift their head the exact same measure. So, and here's why. I'm going to flip you back to geometry, okay? So let's flip back to geometry class for a little while. What, 10th grade you guys were in geometry, or 11th or 9th or 10th grade? Back in geometry class, you learned that if two lines were parallel, cut by a transversal, that alternate interior angles were congruent. Now, you learned that for a purpose. You might not have realized it, but if the alternate interior angles across the transversal are congruent, that's these two angles here. They'll always be congruent. So the 15 that's here matches the 15 down there. So let's put that 15 degrees right there, because we need it inside the triangle, right? Okay. Another thing you can do, that's a 90-degree angle. Let me show you again. That's a 90-degree angle. We could also ask ourselves, what plus 15 would give you 90 degrees? Wouldn't that be 75 degrees? So you're welcome to also put 75 degrees up there in the top corner, because they're always going to be complementary. Oh, another geometry term. Okay. So they add up to 90. Think about this triangle has to add up to 180. So if this is 15, this has to be 75 because that's 90. However you slice it, you're always going to get the relationship that you see there. Okay. Now let's say that we wanted to use this bottom corner, that 15 that we started with. We were given 15, let's use 15 as our theta. Let's label it as theta. What do we have? Well, this is opposite theta. This is our hypotenuse. Of our SOHCAHTOA, the one that we want that has opposite and hypotenuse is indeed a sine again. So the sine of theta is opposite over hypotenuse. Let's use substitution and plot the stuff in. Our theta is 15 degrees. Our opposite is 10,000. Our hypotenuse we've put in as an x. Now you didn't have to use x. You could have used any variable you want, but usually the sides are a letter, angles are a Greek letter. Okay, to solve this equation, I'm just going to leave the sign of 15 here so I can show you an exact way to put it into your calculator. We're going to cross multiply by x. It's always the denominator crosses and multiplies. So wouldn't this be the sine of 15 times x has to equal 10,000? So think about how we would solve for x. We would have to divide off the sine of 15. So just make sure your calculator is in degree mode. So x is going to equal that 10,000 divided by the sine of 15. So if we put 10,000 divided by the sine of 15, since we are looking for our hypotenuse, we should expect to get a number that's bigger than 10,000. So always just keep that in the back of your mind. Our final answer in feet is 38,637 feet. And that's to the nearest foot. The tenths place was a 0, so it didn't round up. Okay. So tomorrow and the next day, we're going to be focusing on those problems. Yes? Yes. Great. Okay. So somebody told me that they used a cosine of 75, and they used the adjacent was 10,000, and the hypotenuse was x. What's very, very interesting is if two angles are complements, you know, they add up to 90, the cosine of one is exactly the same as the sine of the other. So it's kind of an interesting thing that you found. So if one person did this problem using 75 degrees and they decided to use a cosine, yay, you're correct. If you decided to use a sine, yay, you're correct. You decide. So usually there's more than one way to do these problems because sine and cosine have that good relationship. One person uses a cosine, one person uses a sine, we get the same thing. So good to go. Yeah, so that's a good rule of thumb. You can do that. Okay. Are we good with example 6? Yes. No problem. No problem. Okay, one more. Now, of all of the angle of elevation or depression problems, this type is the most complicated, but I think it's kind of the coolest. So I did want to see this. I call it the nested triangle. There are two triangles that are kind of mushed together. Let's take a look at example 7, and then we're ready to talk about the homework. In example 7, it says that person's hiking. They are standing out from the mountain. They look up. They look up to see the top of the mountain, and they have to lift up their head 25 degrees. They walk in 10,000 feet. Now they're closer to the mountain, so they have to lift up their head 28 degrees to see the top of the mountain. How tall is the mountain? So that's why we have an X here. The hiker was here. They walked in 1,000 feet. That's why we have 1,000 here. And then we put the angles in their appropriate location. I am going to add one thing to our triangles. Could you please make this a y? And that is the distance from here to the under the summit of the mountain. Okay. So the first thing you want to do when you're doing a problem like this is you want to uncombine the triangles. So we want to draw them each separately. Now, these aren't going to be to scale or beautiful or anything, but it'll get you the information. So let's talk about the biggest triangle. So before this hiker walked in, this is X, this is 25, and this is 1,000 plus Y. Okay, so that's your first triangle before your hiker walked 1,000 feet. Okay. Now let's draw kind of the smaller version. When he or she looked up 28 degrees. So the hiker looked up. The mountain is still X high, but this time it's a Y. Okay. Now, what we're going to do for each of these scenarios is we are going to set up the appropriate trig function for what we have. Now, we don't have the hypotenuse for each. For each of these, we have an opposite and an adjacent. So let's label those. The trig function that uses opposite and adjacent is tangent. So let's set up a tangent that goes with each of them. So the tangent of 25 is opposite x over 1,000 plus y. The tangent of 28 is the opposite x over the adjacent y. And I'm going to let's keep that one in parentheses. Now, we are trying to find out what x is. If you'll notice in our two different formulas, x is kind of the most prominent, easy kind of variable of them all. It's in the easiest location. It's the nicest. So what we're going to do is we are going to solve for x for both of these. This is just a systems of equations. It's a linear system. It's actually a nice system. It just looks disgusting. But think about how we would get the x by themselves. This first one, this would be x is the tangent of 25 times 1,000 plus y. And this would be x is the tangent of 28 times y. Now, both x's are equivalent x's. So both x's are the same. So we can use substitution to blend these two equations together. That's how systems of equations work, whether they are complicated ones or not so complicated ones. You find out what one variable is and you substitute it in. So let's take this information and set it right here where the x is. Okay, let's do that. Let me scooch this up so we got it. Okay. So we know that the tangent of 25 times 1,000 plus y equals the tangent of 28 times y. Now, if those were numbers there, if the tangent of 25 said 6 and the tangent of 28 said 2, we would know how to solve that in a blink of an eye. That's a simple equation. But the tangent of 25 and the tangent of 28 are kind of gross numbers. That's unfortunate. But let's use now a calculator. So let's get the tangent of 25. Let's go maybe 4 decimal places out for the tangent of 25 and the tangent of 28. Let's find out their decimals. Okay. So the tangent of 25 in our calculator is 0.4663. And the tangent of 28 in our calculator is 0.5317. Now it looks a little better almost instantly, right? It's just an equation. We know how to solve equations. You guys know how to solve this equation. We got to get the y's to one side, the numbers to the other. You know, it's just an equation. So let's distribute in the 0.4663. So we have to use distribution. That's going to be 466.3. That 1,000 just moves that decimal place over 3 places. And then we're going to get plus 0.4663y equals 0.5317y. Now, it's just an equation. We need the y's to one side and the numbers to the other. So let's subtract off 0.4663y from both sides. 0.5317 minus 0.4663 is, this one. So we would get 466.3 equals 0. Let's see if that's right, 0.5. Oh, sorry, my calculator's in a funky mode right now. Okay. Why did that show that? Okay. 0.5317 minus 0.4663 is 0.0654y. Now to solve that for y, just divide. So 466.3 divided by 0.0654 is, to the nearest, because it rounds very nicely to a whole number, 7,130 feet is y. Okay. Now, unfortunately, we aren't looking for y. We are looking for x. Okay. Now, x we should expect is smaller than that number because x is across from the smallest angle in the triangle. So if you were thinking about, you know, should I get a number bigger than 7,000 or less than 7,000? It should be less than it. But we know, look at this right here. Let's write it over here. X is the tangent of 28 times y. Well, we just found what y was. Y is 7,130. Now remember, the tangent of 28 was 0.5317. If you forgot that, just throw it into your calculator. Y is 7,130. So 7,130 times 0.5317, or the tangent of 28, if you want to enter that in your calculator, is 3,791 feet. So the height of the mountain is 3,791 feet. So those nested triangles, I call them, when you have two triangles in the same situation, you want to pull them apart. Many times you're going to get a tangent you want to use. Solve the system of equations that you get. And there you go. So it's a blend of many algebraic techniques that you know. Set up the trig function, get two equations, use substitution, you got it. Okay. Do we have any questions about example 7? Do we have any questions about example 7? Okay, so those are the types of examples that are in homework. Let's talk about the homework. As soon as everybody's done writing this, let's take a moment and talk about your assignment. Okay, so if you'll notice, the first 4 problems look like example 1. You're going to find the exact values of the 6 trig functions. That word exact values means that I want the fractional equivalent. Okay. Problem 9, 10, 11, and 12 look like example 2, anything labeled example 2. You're going to draw a triangle for each of those and then find the 6 trig functions. So like for this, I know that the sine is 4/5, so I'm going to draw a triangle that has the opposite 4 and the hypotenuse 5. I am going to use Pythagorean theorem to find my third side, just like we did before. 9 and 10, find x to the nearest tenth. 31 and 32 is like example 5. You're going to find the degree to the nearest whole degree. You're going to have to use that second button. So far, the only time we're going to have to use the second button is on 31 and 32. These are some applications. You're going to draw the picture. If you need help drawing the picture, let me know. Problem 40 and 41 are bonus. Okay. These are due by the time I see you tomorrow. They are due by the time I see you tomorrow at the beginning of class. So if you have any questions, you can answer, or I can answer those at the beginning of class. Okay, so there you go.